Hey, how's it going, everyone? Welcome to the stream. So a couple nights ago when I streamed, we implemented, let me see where it is here, the noise generator, yeah, right here in front of me. And that totally worked out. So let's do a little demo of that. Just stop the music here. Bring this over here. So this noise channel can really be heard when I'm moving my ship here. That like high screech sound, that's the noise channel. And when I fire, there's a mix going on. A mix going on of the square wave generator and the noise wave generator. So there's like you can hear a tone and the noise. And actually not the explosion. That explosion you hear is because I blew up one of these guys, right? And the reason why it keeps going is because we haven't implemented the volume envelope. And that is almost surely used to basically bring that explosion down to zero. So that's what we're going to be focusing on tonight, is trying to implement the volume envelope. Can't ever say that word properly because coming from Montreal and speaking both French and English, I just seem to say that word incorrectly in both languages. Anyway, envelope, the envelope generator control here. So that's basically what we'll be focusing on. And actually, before I get started, I'm just going to go grab my coffee. So I'll be right back. Okay, trusty coffee here. All right. Okay. All right, so let's do a little bit of reading and start preparing how this is going to work. To accomplish the generation of a fairly complex envelope patterns, two independent methods of control are provided in the PSG. First, it is possible to vary the frequency of the envelope using registers R13 and R14. And second, the relative shape and cycle pattern of the envelope can be varied using register 15. The following paragraphs explain the details of the envelope control. Hey Pyro, nice to see you. See you. You've been joining the stream more often. That's really cool. Hold on. Spinning chair, spilling coffee. All right. The only downside to implementing audio is that I can't play my music. And I really like working to background music. It's like so quiet now. But it's okay. I'd rather not keep starting and stopping the music. When I work late night shifts, I can cache the streams sometimes. Cool, man. Really happy about that. All right. So basically there are two channels for controlling the frequency, sorry, two registers for controlling the frequency. And I can see it looks like it's extremely similar to the way the what I'm looking for, the tone generator works, which also uses two registers. Although the tone generator is a 12-bit pattern, here we've got a 16-bit envelope period, not pattern, period. And then the shape of the curve, like how it behaves, is all in register 15. And I know this time these are octal values, so I won't get confused. I believe I already mapped these out in here. Yeah. So that's actually in decimal 11, 12, and 13. So note that the 16-bit value programmed in the combined coarse and fine-tune registers is a period value, right? So the same as usual. It also does with the tone period. The lowest period is 1, and the highest period is this. So actually, let me see here. So yeah, so most likely I'll just be using a timer, similar to how I did it in the other two. Yeah, exactly. Perfect. And I think this timer here is one that, let me see. Oh no, that's it. The min 1 thing is taken care of when we set the timer. Yeah, there it is. Perfect. The envelope frequency equations are there. That's good. To calculate the values for the contents of the envelope. So actually, before I continue, let's start modeling this. We'll have a timer in there. We'll have a way to set the period. In fact, I'm going to have to do similar, not like this. I'll have to do set period low, set period high. Very similar to what I did over here. In fact, it'll be almost exactly the same. What I'm gonna do, I'm just gonna copy all of this, and then we'll adjust. So this is not the case. Why did I? No, it is like this. Update timer, sets the period low. All right, and that's pretty much all the same here. Now, of course, this is not going to be the same. Also, we're not going to set the period to a duty value. At least I don't think so. So something more like that. And this is the interesting bit. The envelope generator further counts down the envelope frequency by 16. By 16, eh? Just give me a second. Okay, it's the same thing. They just mean the top level divider. Okay, that's fine. So, okay. So, the envelope generator further counts down the envelope frequency by 16, producing a 16-state per cycle envelope pattern as defined by its 4-bit counter output. Okay, so the envelope control uses those 4 bits, and I wonder if they do mean, though, that there's an extra weight, if there's an extra divider here. See here. Oh no, look, see, this is interesting. The frequency of the envelope is obtained in the PSG by first counting down the input clock by 256. Okay, so I think that's what they mean. So we have the top level divider. That is already doing 16. Oh, that's interesting. So I think that just means that's what kind of explains the further counting down by 16, because every 16 of the top level divider, then in the envelope there's another divider that weights 16 more, right? Does that make sense? So then 16 times 16 is 256. So that would make sense. So that would mean, if I understand correctly, that we need like 2 different timers in here. Or actually, what do we call this one? A divider? What does my divider do anyway? Oh yeah. How different is this from... What is this even doing? In fact, it's kind of hilarious. My divider is a timer. I independently wrote this last time without realizing that I wrote exactly the same code right above it, or almost exactly the same code. So funny. I think I'm gonna get rid of this and just use timer, because it's the same thing and it makes just as much sense to me. Alright, so I'll put a little to-do here. Get rid of this and just use timer. Off topic, when all this is done, are you going to make a little write-up of how you program this and why you use certain programming techniques, algorithms to achieve your Vectrexy? That would be a cool read. Like, I'm really bad at planning how I'm going to code something, probably due to inexperience, and I get stuck really easily. I have thought about it. In fact, often I've thought about it while I'm writing Vectrexy, like, you know, oh, that was a cool thing I did. I should probably write about it. And then I don't do it just because time. Like, it would probably take me like I only really have a couple of nights a week where I can do this kind of thing, you know, and I choose to stream and actually work on the project. Otherwise, I'd just not stream and do my write-ups instead. So that's mainly why I haven't done it. Also, write-ups are really a lot of work, you know, like blog posts and stuff, if you want to write a high quality one anyway. So that's sort of why I haven't done it. But now what you've been asking me and I have been thinking about it is, you know, once I can like kind of claim I have a 1.0 version, and we're getting there, about like, should I go ahead and write something? And I think that would be a cool idea. I don't know if I want to do like a one post that's like about the whole project, the experience of doing this project, and even about streaming it. I think that's kind of interesting. And then there's also, you know, do I want to write like separate posts about how I solve specific problems or interesting bits of stuff? Like one of the things that's interesting in this project is my usage of C++ 17. Not a lot of people are doing projects with C++ 17 because it's fairly recent, right? Or if people are doing it, they're, I guess, not streaming it. I haven't really caught that many C++ 17 specific streams. So I think some people would find that interesting, you know, to kind of like talk about some of the nice things about it and things I really liked, things I don't really like, things that are not quite there yet. So there's a few things like that I feel like writing about. Yeah. So yeah, definitely. And as to your point, Pyro, about being really bad at planning, so I'll tell you a little secret. I think most people are. I'm pretty bad at planning how I code. I think you might notice that I am very much the type of programmer that just sort of explores, you know, just kind of writes code. And I really think after having, you know, done this for a little while, I think that's the right approach. I know you can, I plan a little bit, right? Like I have a sort of like a general idea in my mind of where things will go, but it changes so much. And so what I prefer to do is to just write some code, you know, and maybe it's a mess and maybe it's in the wrong place, but it'll kind of get reshaped. I feel like a little bit like code is like clay, you know, and you sort of lump everything together and it doesn't look like anything. And then as you keep working at it and you move things around and you remove bits and pieces and you separate and you refactor and all that, suddenly that big lump of clay becomes a statue. You know what I mean? So that's sort of how I treat code. And you can see like this is totally work in progress. Like that, I have all these classes here that don't really belong here in the header file. And in the back of my mind, I'm like, oh, I'm going to move this. But it's not time yet. You know, I just want to get this done. I have a lot of those in, you know, to-dos and little things I want to do to clean up. But it's okay because it's better to focus on just getting the thing done with a reasonable amount of clarity. You know, like you don't want to make a huge mess, but at the same time, you don't need to go crazy. You know, so I don't do like, I just, you know, the kind of over-engineering that I used to do when I was younger, or I see a lot of people do, just a bunch of abstract interfaces everywhere and writing code with, you know, the kind of like guessing what the entire interface of your class is going to be and putting all the functions you think it's going to need first and then afterwards writing them. Or I don't really prescribe to that. I just more write what I need right now and do it simple and straightforward, plug it up, see how it goes, and refactor as needed. So if that helps you feel better about the fact that you get stuck or you don't know how to organize, you know. I do that too, but then I get stuck on one thing because the code isn't right for it. Yeah. Oh, for sure. And you're not alone. I get that too, you know. There's some frustration I have already in this project, and you know, I think a little bit about it, and the frustration you're talking about, I feel it. And I kind of let it sit in my mind for a while. I let it stew, you know. I tend to solve those problems in the shower or in bed when I'm lying down just thinking. I kind of think, you know, what am I going to do? How should I organize this? And usually it comes to me, you know. I usually go, oh yeah, you know, maybe I should do it this way. And then I go, and then I'm kind of excited to refactor the code and make it work that way. So yeah, don't give up. I think one of the most valuable lessons is step away from the code and let your mind chew on it for a little while. I mean, look, I just pointed out that I have two classes that look almost identical and do the same thing. One counts down and one counts up. That's pretty much the only difference, right? In fact, no, they're exactly the same. It's so hilarious. Look at that. It's so funny. See, doesn't that make you feel better? Even the dude with like over 20 years experience is doing stuff like this. Whatever, right? That's part of the deal with streaming this. I want people to see that all programmers of all types of experience, we all make mistakes, we all do stupid things and whatever. It's part of the game, right? In the end, we're just trying to get something done and hopefully it works out, you know? All right. So let's do a timer, and I'll call the name of this timer divider, and then I'll call the other one a timer. And what we'll do is we'll set. Okay, yeah, there was something about. That's one difference with my divider is this one had a constructor. So I'm going to do the same thing here. In fact, I can just copy it. And this set period does a reset. That is a difference too, though. Setting the period here does a reset, whereas my divider did the reset in the clock function and didn't do it on its set period, which doesn't make any difference. So yeah, okay, let's do that. And now this way, I can do 16. And I'll say here, envelope further divides by 16. So it clocks, or it produces values every 256 cycles. It's funny how you're amazed at how you managed to make two identical codes. You don't think that's funny? You don't think that's amazing? I mean, because what happened was I wrote this, you know, like a couple weeks ago, the divider. It was when I started working on it, I wrote this. Then later on, I wrote a tone generator, and then in the tone generator, I had code like the timer. And then I was writing the noise generator and realized, oh, I need the same thing. So I factored out the code from the tone generator into this timer class and used it in the noise generator as well. But without realizing that as I was factoring out this code, I was effectively rewriting the divider code, because the divider is just a timer. But it had never clued into me, because like there's a delay in time between these two, and they're literally one above the other, you know? Isn't that amazing to you? Or funny? Anyway. Right. Yeah, I can imagine. Sometimes I don't realize the faces I make. Like, one thing I didn't realize is that when I'm programming, I touch my face a lot. I didn't realize this until I watched videos of myself. You know, sometimes I'm watching my videos because I want to like edit parts, like cut out parts and stuff. And I'm watching and I'm like, man, my hand's always on my face. I'm always like, you know, this, like this, like this. So now like I'm actively trying not to do it too much, because it's like, you know, but I'm surely once I get concentrated, I'll start doing it again. Things you don't realize until you watch yourself. All right, so we got this, and then what we'll do is we'll just add a little clock here. So we'll just say if the divider clock, so if not, I'll just do this. And then when it passes, we'll check our timer, and the timer is actually the period timer. I just got notified that you liked my my tweets, Pyro. Okay, next. All right, so actually let's hook up the set for these two. Whoops, I want period high. I need to add an envelope generator. Period high, case register, envelope, period low, return period low. For the right, very similarly, just get these in the same order. That's 7, 6. These are higher up. So here we're going to say return set period high to value. I'll set the period low. Okay, so let's just make sure this all builds. Just want to make sure also that I didn't mess up what the timer, because I did change it to have that constructor, but it should be fine. Okay. Back to the dock. Now here's a part where we need to do this. Producing a 16-state per cycle envelope pattern as defined by its 14-bit counter output. The particular shape and cycle pattern of any desired envelope is accomplished by controlling the count pattern, count up, count down, of the 4-bit counter, and by defining a single cycle or repeat cycle pattern. Okay. This envelope shape cycle control is contained in the lower 4 bits of register R15. Each of these 4 bits controls a function in the envelope generator as illustrated in the following. So we have hold, alternate, attack, and continue. The definition of each function is as follows. Hold, when set to logic 1, limits the envelope to 1 cycle, holding the last count of the envelope counter. Depending on whether the envelope counter was in a countdown or a count up mode, respectively. Alternate. When set to logic 1, the envelope counter reverses count direction, up or down, after each cycle. Okay. Right. Attack. When set to logic 1, the envelope counter will count up attack from, let me just see something. Okay, so they call the internal counter, the 16 value counter, the 4-bit counter, E3s to E0. So it's the E. That's what they're talking about here. So when set to 1, the envelope will count up from 0 to 1111, and when set to 0, the envelope counter will count down, decay, from 1 to 000. Continue. When set to 1, the cycle pattern will be as defined by the hold bit, and when set to 0, the envelope generator will reset to 000 after one cycle and hold that count. Let me see if I understand. So if continue is set, it looks at hold. If continue is not set, then the envelope generator will be reset to 0 and after one cycle and hold at that count. So this is kind of like a little bit like more of like an enable thing, isn't it? Saying it's sort of like if you don't want any more sound, you probably just set this to 0, and then it'll finish its current cycle and then go to 0 and hold it. Yeah, I agree. Alternate looks like it's for sawtooth, and we're going to see the shape very shortly. There's here. To further describe the above functions could be accomplished by numerous charts of the binary count sequences for each combination of hold, alternate, attack, and continue. However, these outputs are used when selected by the amplitude control registers to amplitude modulate the output of the mixers. A better understanding of their effect can be accomplished via a graphic representation of their value for each condition, as illustrated in figure 7 and 8. However, since these outputs are used to amplitude modulate the output of the mixers, a better understanding of their effect can be okay. All right, graphic representation of envelope generator. So let's see if we can make sense of this. So basically, I think the X's just mean we don't care. So if continue is 0, I guess attack is 0. It's going to finish the attack cycle going from 1 to 0, and then it'll hold. If continue is 0 and we had attack 1, it would go up once, finish that cycle, and then go down. Yeah, X's don't care. Clearly, in these cases, we don't care. Because when continue is 1, then we look at hold. So the rest here is always when it's 1, so we can pretty much ignore that. If hold is 0, that means that we just don't hold the pattern. We can see that when hold is 1, after the cycle is over, it holds it. Here as well, after the cycle here, it holds, hold, and hold. Otherwise, it alternates. So here, when we have no hold, attack is 0, so we're going from 1 to 0, and we alternate, it produces this. I guess that's called a sawtooth. So let me see here. Attack is 0, so we go down, and when attack is 1, it's the opposite. We go up. These are the opposites. Yes. Here, attack is 0, so we go down, but alternate is on. So alternate determines whether we go back up. Right. Detail of 2 cycles. Right, so one cycle of the timer, okay, during, oh, that's interesting. Yeah, all right, that makes sense. So if I understand correctly, basically every time we clock, we move to the next thing. Right, this is triangle over here, right? And these are called sawtooth. Okay, and then that's it. Yeah, so if I understand correctly, basically the idea is that whenever we get the timer clocked here, so this will be every 256 CPU cycles, we move to the next thing. So we'll be holding this for 256 cycles. No, not 256. Actually, 256 plus whatever our timer is set to. So this is an extra 16 over the master divider, which I have in here. So let me actually write that here. Divider. Yeah, I said I was going to replace this. I called it the master divider because pretty much everything is first CPU frequency divided by 16. So I have that here. And then I go and I clock these guys. And so in here I'm actually going to clock my envelope generator. There. Okay. So there's kind of like two ways I could do this. I could see, I'm touching my face again. I could make a, I wonder if I should do that. I could make like a shape table and just, use this to index it. And there's going to be this thing about whether or not I'm going to have to respect whether or not like I loop back or not through the values. That might actually be the simplest way to do this. Because it's either that or I really try to emulate how each one of these works, So like, oh, if continue is on, what do I do at this moment? Like a little state machine, effectively. The envelope frequency based on the CPU or based on the PSG? It would be based on the PSG from what I'm reading. So like basically that's what I was kind of figuring out earlier here in the docs. So at the top it says here, hold on. So you see here it says the frequency of the envelope is obtained in the PSG by first counting down the input clock by 256. And the way I read that is it's effectively 256 because then later on it says the envelope generator further counts down the envelope frequency by 16, producing a 16, right? This here tells me that there's basically a second divider in the envelope generator. So there's a divider in the PSG that divides by 16 the CPU clock. And then specifically in the envelope generator, we further divide by 16, and then we divide by the frequency by the timer value that's set, the 16-bit value. At least that's how I understand it. So 16 times 16 is 256, and that would explain why they wrote 256 up here. It's a little bit confusing how the text is written, but that seems to be correct. I can kind of reason about it that way. And maybe I'm wrong, and we'll hear that it's wrong, and we'll try different things. You know what I mean? But I don't know. I get a good feeling because the fact that they wrote 256 here in this equation, they basically wrote the envelope period here is 256 times the coarse tune register plus FT, which is the fine tune register. Is that right? Yes, that's right. Let me see up here, just to make sure I'm not wrong here. It's very confusing. Yeah, so here it's by 16, and where is it? Oh no, let's not use the noise. Let's use this one here, the tone generator. Oh, they put 256 here as well. TP10 is 256 plus course times course tune plus FT10. Then that would mean, so maybe I'm wrong. Maybe there isn't an extra divide. I mean, here they write 256 and above they wrote 16, but then when we look here, this is exactly the same as what was the equation for the tone generator. But then it says the envelope generator further counts down the envelope frequency by 16. I don't know. You know what? We'll see. Yeah, I mean, I agree with you, but this documentation is not super clear. Honestly, I don't know. It's not super clear. Yeah, it's really confusing. But look, we'll hear it. If it sounds wrong, I can just as easily, you know, turn off that divider and see if it sounds better. We'll compare. We'll use our ear to figure this out. All right, so back to this. Like, I'm kind of playing in my mind whether or not I should go with something that's just table driven, which might be just like the simplest way to do this. And I'm really leaning towards that. And that means at most I'll just have 32 values for the shape. Or, like I said, I could code up a little state machine. I'm tempted to try this with a table. In emulation, you know, we want this to go fast. We have memory, and I think it won't be too hard with a table. And if I see that's not working out, we'll switch to writing a state machine. So let's give that a shot. Okay, so what will this table look like? It'll be kind of like this. Let me put this over here. Lookup table sounds good to you? Sold. What is it you don't like? What's all this red? Nothing. Okay. Just Visual Studio freaking out a little bit. So I had this before like that. And we'll do a nice little lookup table of UN32 values. We'll do oh, because of the don't care, we're missing some entries. Interesting. Okay, so I'll just copy those. Keep it simple. We will also want it to be Let me see if I can do this. Table. Okay. So for the top entry, it's going to be basically 15, 13, 12, 11. Zero. That's 16 values. And then zeros for the rest. Actually, that's one thing I wonder is, down here, will there be two successive zeros? Maybe, eh? There will be. Pyro says yes, so we'll go with that. And then we'll go with 16 zeros. You know what would be really cute here? I want to be cute. I won't be cute. And then basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right. It did, right? Okay. This might get formatted like that, yeah. I think I'm gonna ask it, Clang format, not to format this for me. So I'm gonna do that by putting a, what is it again? Clang format off. It's a bit of a shame how I'm gonna have to like duplicate this. Maybe I could do this a bit more intelligently. Okay, I won't be too smart right now. So this is 0, 0, and then 0, 1. Oh, I do kind of want it to remove those tabs, but anyway. So 0, 0, 1, 1, 0, and 1, 1. And then we move to 0, 1, 0, 0. And after that, I think it's all, they're all there, right? Yeah. 1, 2, 3, 4, 5, 6, 7, 8. Oh wait, I'm missing. I don't think I got that right. Oh no, then this next one also has to have 4 entries that are the same. Yeah, that's right. Okay, so the next one will be the opposite order. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Did I get that wrong? 0, 1, 1, 1. Oh, okay. It's okay? I got it right? It's possible, you know, that I'll make a mistake here. This is kind of annoyingly meticulous, but anyway. All right, so that looks okay. So 4 of these. Okay, and the next one is 1, 0, 0, 0. So what do you don't like here? Too many initializer values, really? What did I do wrong? Does this compile yet? Oh no, too many initializers. I do have something wrong here. That looks right. Oh, right. I think it's because I have 32 values. Will this really be 32 values? Should be 31 values, right? Or is it 32? We were saying that it goes from 15 to 0, then 0 to 15. So it actually is 32 values. No, it is, what am I saying? Yeah, there are 32 values. Yeah, that's right. Getting confused. So what's the problem here? Let me try something. Okay, so the pattern is fine. It's the table, which is an array of 16 of these patterns. I might be having an issue with using the initializer for std array here. I thought I could do the way I was doing it here. Oh yes, I think I know. I have to do it this way. I think that'll be happy. Let's see. Oh, is this one too many? 0 to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. Thank you, Visual Studio. Okay, that's good. Looking good. I really like using std array exactly because of the fact that, first of all, the compiler can tell me when I have too many initializers, and secondly, if I make an out of bounds access in debug, it'll actually assert, and that's just a huge time saver. Because especially with tables like this, it's very easy to access out of bounds and get the next value and not know about it. And this way I won't be able to do such a thing. It's just going to be really, really nice. Basically, if you're working in C++ 11 and up, don't ever use C-style arrays anymore. Just always use std array. That's my advice to everyone. You'll just save yourself a lot of hassle. And you get so many benefits too. Like you can use all the algorithms, iterators, all that. And because it's not a C-style array, it's actually a class. You can it's got copy semantics. You know, you can copy them around just by assignment, which you can't do with C-style arrays, right? Because C-style arrays are both they decay to pointers, which is really a big mess. If you pass them to a function that takes a pointer, it'll decay, and you have to pass a size. Std array has its size in there. There's like just basically nothing wrong with std array, and everything is wrong with C-style arrays. So Pyro, if you're working in C++ 11 and up, use std array. All right, next pattern is this one here, right? So this one here is basically the same as above, repeated. So 15 to 0 and then 15 to 0. Cool. And this is 1001. You mostly use C. Is that by choice, or it's your company's choice? Because I mean, I know a lot of embedded shops now that are moving to C++. You know, judicious usage of it, but you get a lot of benefits, even performance benefits, from using C++. So 1001 is over here. So that's exactly the same as this up here. Choice, I've always managed to do what I need in C and never really got into C++. Man, you should totally check it out. I mean, it's really C, but with lots of nice extra features. You know what I mean? So this one is down and then up. So 15 to 0, and then 0 to 15. I guess I don't have an up pattern yet. Yeah, it's the first time. Oh no, what am I saying? It's right here. 0 to 15. One, 0, 1, 1. You never got to the OOP part. So if you're learning C++ and you don't get to the OOP part, that sounds like, let's learn C first. Except, let me guess, you learn to use std cout and cin and endl. That was the C++ portion of the program. Yeah, no classes. So basically it was C with cout. Yeah, there's kind of like this new thing that's being pushed into the C++ community, which is stop teaching C when you teach C++. Yeah, exactly. Like, don't teach C and that basically C and C++, they're, you know, C++ is backwards compatible mostly with C, but if you're going to program in C++, there's a whole different way to do it that is not the C way. Like I was saying, don't use C-style arrays, right? We never use malloc or free or new and delete. Like in this program of mine, I have no new or delete anywhere. We use a unique pointer, shared pointer. So it's really a different paradigm to do C++. And so to teach people C++ by first teaching them C is a bit of a disservice. At least that's kind of like the common the common feeling anyway in the C++ community. It's relatively recent. Of course, I learned C first, and you know I'm kind of old school, and I've got the bottom up approach type of feeling where I learned how it works at the lower levels, and I learned the abstractions and stuff that C++ provides in terms of those that are in C. But I do see the argument that C++ is already complicated as it is, especially if you include all the C part of it. If you want someone to learn how to be at least productive in modern C++, you can kind of ignore all that stuff and focus on that subset that is really pure C++, modern C++, that makes life easier. And then, you know, with time, you can kind of learn all those old backwards compatible C features and esoteric things, you know what I mean? Kind of top-down approach instead. And I don't disagree with it, because it's hard for me to see it because of my own experience, but I can imagine what it's like, you know? Okay, so 1011 is down, followed by all ones right after the 0. So here we're going to go and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Hey, fake Pyrie. I don't know, I kind of feel like C++ is in an awkward position these days. C is still very relevant because C-style APIs are the common interop language. Yeah, that's true about it being common for interop, but I don't know if I would say it's in an awkward position. I think it's actually become a pretty nice language to use. 1011, 1100. And I mean, and this is speaking from, you know, I've learned different languages. You know, I've done Python and F# and C# and what else? I've been learning Rust recently. So I see all these different languages and what I've learned Scheme and Lisp in the past. So I see like different angles, you know, OCaml is another language similar to F#. And all of these languages have their plus and minus, but C++ up until before C++ 11, I had done quite a lot of C++ up to then. And when I learned those other languages, I was just like, man, C++ is hard. You know, it's hard in the sense that I can't do all these cool things. It's so annoying, and there's just so much boilerplate I got to write to get things done. Since C++ 11, when they added many important features to the language, and it's then 14 and now 17, it's a different language, right? It's got a lot of the power of these other languages, and it's way more expressive. C++ 20 will continue to build on that. So no, I think it's going in a good direction. Oh, did I make a mistake? Pyro's pointing something out. Yeah, see, if I'm talking too much, I'm not paying attention. Let me see here. 1011, 15 to 0. Oh, yes. Thank you. Thank you, Pyro. That is, you have good eyes. So let's do that. So this should be 15, comma, let's paste that 15 more times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'll do it one more, and I'll use Visual Studio to tell me that I went over, if I did. No? One more. Come on, IntelliSense. You can crunch through this. But I'm not saying C++ is perfect by any means. Definitely, there's a lot of dark corners in the language. You know, one of the problems, one of its greatest, one of the great things and also the worst things about C++ is the fact that it's backwards compatible with pretty much old code bases, you know? Why isn't this complaining? Let me just compile. Yeah, too many initializers. Oh, did I fuck up? Yeah. Okay, beautiful. So that's 1011. Then 1100, we're going up, up, up. So this twice. 1101. Go up, and this time we go up and hold 15. Okay. Just add one more for kicks. Yeah. 11, where were we? 01, 1110. So there's the inverse of that, so it's up and then down. And finally, our last pattern, as we go up and then we hold 0, which is actually what I had written before, I think, when Pyro pointed out my mistake. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Let's just see. Yeah. Okay. And then one more thing, I want to replace my tabs with spaces in here. So since I'm not Clang formatting this, I end up with the spaces that come from Visual Studio. And I don't want that. Okay. So there's our table. I'm just going to put a little comment here that basically it's is it lookup? Lookup? I don't even know. How do we write lookup table? It's one word. There we go. Okay, so we've got this lookup table. So we're going to want to have a current index into there. We're going to just advance the index and then just return the value, and we're going to want to, that's it, right? Well, yeah. Yeah, that's one thing, of course, is that if we're in those states where we don't loop, then we're just going to have to hold the last value, basically. After one cycle. Is there a difference between 01XX and 1111? Zero one XX. I guess not, is there? I guess it's the same. Yeah, it's the same. I mean, another way I could have done this is I could have like named these shapes and then in this table just put the names of the shapes. You know what I mean? I don't know what I call them, but you know. There's many ways we could have done this. But I don't think it's a big deal. It's just it's pretty simple, this lookup table, right? So should be fine. And I might get really pedantic and like space these out and align these. But I will not. If I used hex, I guess they would all be lined up, but whatever. The EP at the bottom is just one cycle. I thought it was specific to the 111 pattern. Oh, yeah. This table contains 2 cycles worth of values. Yeah. So let me see here. It looks like basically I only have to care. No, that's it. If this is 0, we definitely just hold. Otherwise, if hold is 1, then we hold. Yeah, exactly. So we really need to look at both continue and hold to know when to, like, once we reach the last, what I'm going to do is I'm going to basically go all the way through for 2 cycles. And there's also another thing I'm going to have to manage, which is if a change occurs, I need to kind of finish the current one. That's going to be a bit annoying, actually, now that I think about it. That's one, I guess, downside to using the lookup table. There's going to be a slight bit of complexity with managing the... Oh, no, that's okay. Yeah, that's going to be okay. Let me think. Yeah, a little bit. Like, I'm going to have an index that counts through the table, but when we finish one cycle, we may need to change... Yeah, we're going to have to set up a target pattern, and then it's only when we get to like... And that's okay. Is that okay? Yeah. Because he keeps saying, like, you know, in the documentation, you don't really... I guess you don't change in the middle. Oh, no. You can change in the middle. No, what am I saying? Sorry, thinking out loud here. Let me just... Yeah, okay. Should be okay. Yeah, should be okay. So let me actually, can I move this? Kind of don't want it in here. Damn it. Okay. Does that work? No, oh yeah, hold on. can't do an initialization of a static table as a data member. You switched the bit pattern in your comment. Did I? Did I make a mistake? Oh, you're right. Oh, it's the other way around, of course. It's actually 3, 2, 1. Let's do that. That's more clear. Okay, you know what? Fucking annoying. Clock, and then we'll say I guess I could just use this, and I'll do something like this. Okay, so now we need the function to set which one it is. So we have a set shape. Let's hook that up right away. So when we set the shape, we'll also reset the pattern index to 0. That looks good to me. In here, after we've declared our table, we'll say what? What's wrong with this? Oh, right. So we get a pattern, and we will say that because we've been clocked, we will get the next value, no, the next pattern index. I'll do that after. And we'll say, give me the value at the current pattern index, like that. And now here we want to do plus plus, and actually we want to do this equals to that plus 1, you know, modulo, and it'll be 32. But here I think I can just do, can I get the size out of here? Const expr. No? Should array expose its size? Oh, that's too bad. Oh, that's a missed opportunity for useful stuff. Okay. But we can get it from the pattern itself. But before we do that, we want to know whether we should hold it. So we'll say we'll ask if we should hold it if our current pattern index is equal to the last value. I'm going to get a type mismatch thing here, but whatever. And it's kind of annoying, but okay. What do we say? It's we're going to check continue. Actually, I'm going to do this a little bit differently. We'll let the compiler generate this code more efficiently. And then we'll say if. So if we are in the last one, if we're not in the last one, return false. If we are in the last one, and this pattern table index, it's really the shape. I don't know if I should call it shape. We saw us setting it here, but anyway. And basically we want to know if it's set, if continue is 0. So if B3 that's the continue. Can't call it continue. So if not continue, return true. So then this is not like that. I want to call it continue. Do you know of any online courses for C or C++ programming? I do. I do because, but yeah. I've looked at some for, what's it called again? Pluralsight. You know Pluralsight? This huge like site with like millions of courses for all kinds of stuff. There are some pretty good C++ classes on Pluralsight. And in particular, I remember looking at some from Kate Gregory. See if I can pull that up for you. Do a little bit of free advertising. So Pluralsight. Oh look, I searched for Pluralsight and Kate Gregory came on. She's really great. She's been doing C++ for a long time and teaching it for a long time. So let's see if I can find, here we go. She's in her 4th decade of being paid to program. So here we go. C++ fundamentals, including C++ 17. This was recently updated. She had a course before that. So you can see a lot of them are on C++. And I didn't watch this updated one, but I watched her last C++ fundamentals course over here, which she had done in 2011. But since then, there's been C++ 14 and 17, and so she decided to update her fundamentals course. And she said she even improved it. She like kind of reworked some parts that weren't working as well. Then she has like advanced topics. She's got some stuff on Visual Studio. In fact, I think she's the one who's kind of like popularizing the don't teach C. I saw her give a talk at CPPCon, and yeah, she was the one. She was saying like, her talk was don't stop teaching C when you teach C++. And another thing she said, I don't know if that was in that talk or in one of her in a podcast I heard her talking. She was saying that she thinks actually it's a mistake to teach C out, C in, or even printf, but mostly C out and C in. She thinks that it's like for beginners, it's extremely weird. I mean, C in and C out are just weird to begin with because they rely on operator overloading, which, you know, you don't learn until later on. And so for a while, you're making use of these weird constructs that don't seem to fit anywhere in the language until you finally learn about operator overloading. And she also finds like a lot of students get kind of mixed up with how to use them properly, how to format things. And in the end, you know, the rationale for doing input-output is being able to see what your code is doing, right? Like, did I actually get the value I thought? And so what she proposes is instead of teaching input-output so early on, skip that and only teach, like instead teach how to use a debugger. So like apparently in her courses, one of the first things she does is, I think she uses Visual Studio. We can see it in her courses here, but it can be anything, right? But she teaches how to build in Visual Studio and then how to set breakpoints and how to run and step over code and use the watch windows and hovering over variables to see what's happening. And like this is way more informative than littering your code with a bunch of print statements. And not just that, it's a super valuable methodology that you're going to be using pretty much all the time when you program. So may as well start with that rather than the input-output stuff. And yeah, you know what? I totally agree with her. I think that's really cool. So yes, I'd highly recommend anything from her. So if you're looking for something, you know, I know Pluralsight's not free. I think you get like a free month, but yeah, if you're interested, I'd say look at this. Hey, no problem, man. So if hold pattern. So wait, we were saying hold current value. So if, right, if not continue, but if we want to hold, return true. Actually, I guess at this point I can just say return hold pattern. And then I'll just do an immediate invocation. And it doesn't, and I need to pass it pattern here. Okay, now here we say we don't want to hold the current index, then do this. So it's a bit weird, but I think this gets the point across. If we're on the last index, on the last value, then hold if, sorry, then check if we should hold this last value, or restart pattern. Or more like, check if we should hold this last value. Hold it or advance. It's a bit confusing, but anyway. That's fine. I think this is right. Now there is something here about initializing the value to the very first one. After we've set the shape, we will get clocked. But what's the value that we get? So that's one question, right? So if you set the shape, that resets all the counters. I guess value should go to 0 until, yeah, do they talk about that? Like if I set the shape to one of these, does it immediately return this, or do we wait until the next time? Like, I don't know. Like, do I do this? Does setting the shape also reset the value, and then on the very next timer, like once we are supposed to clock, we're gonna get a new value? Maybe. Maybe that's good enough. We'll see. And I'm really getting the feeling like we're not gonna need this divider. That's my feeling. It's either we do this, or we are supposed to actually update the value to the very first one. So we may have to call update value, kind of like get it primed, you know? So it's either reset value or call update value here. what it should be hardware-wise. Because I guess what it is that let's say I set the shape to 1, 0, 0, 0. Are we going to wait 1 EP's worth of time before it finally goes up to 1? I don't think so, right? We probably want it to immediately give us a 1. So I get the feeling like we should be calling update value here. Yeah, and in that way we come in here. Pattern index has been reset. We choose our pattern based on the pattern. Oh, this is wrong. Pattern table index. See, there's a bug right there. Okay, so we choose which pattern we want from the table. And that's been set in the shape here. You know what? I'm gonna change this. I don't like this name. I'm going to call it the shape. I think it makes more sense anyway. This is a table of shapes anyway, right? These patterns are shapes. And maybe this should actually be called shape. Something like that. This is not a shape index. This is a I'll leave it like this. I think I understand it this way. Okay. We are getting close. We can now start actually making use of this. Our value should pretty much always be 0 to 15, so that should work. We clock it. So now what we need to do is pass it in to our sampling of the channel. generator. And then here we say get channel volume. Yeah. Pass it our envelope generator. So if our amplitude mode is not fixed, that means we expect to use the envelope. In cases like this, I prefer to use a switch statement because I think it'll be more clear. All right. So we go for gold, see if it works. Okay, moment of truth. No, not yet. Aww. Nope, not working. But we can at least debug it. So let's see here. For a moment I thought it was working. Let me see what this looks like. Yeah, so it didn't do it the first time. I thought so as well, but it's what happens is that I blew something up, it started the sound, and then another one of the mines appeared, and it went bloop, and so that basically took over that channel, and that's why it ended up stopping the noise. So it's just a side effect of the fact that there's another mine that appeared. Once all the mines are there, though, then when we blow up a mine, nothing interrupts that noise on that channel. I'm going to just remove this divider here because I have a feeling this is making it last super long. Yeah, just a feeling. Let's just see. I'm going to fast forward now through it. So we're going to hear some little pops and glitches in the sound. I'm going to do a thing where when I fast forward, I think I'll just disable, like I'll mute the audio. Because it just sounds awful when I'm fast forwarding. Okay, I'll just wait for all of the mines to spawn. Aha! So that's still slower. Oh, and we got to repeat. Interesting. So we're getting a pattern. It takes quite a long time. And Interesting, very interesting. Oh, wait. Look at that. I didn't do the set of the register shape, of the envelope shape. How did I forget that? Hold on. Just thirsty. So we can hear that when I hit something, it restarts. So the set of the shape, it must be happening as soon as I hit something. Like if I put a breakpoint here, see, as soon as and my keyboard went crazy there. But see, as soon as I hit it, the set shape occurs. If I hit another one, there's a set shape again. And I'm assuming also the set period high and set period low must be called at the same time. Let's see. Oh, I just got hurt. So there's set period low, set period high, and a shape for when I die. Okay, those just got turned off. Let's try this again. Looks like the envelopes get set for when they spawn. There's a hit right there. Set period low has a value of 0 and a value of 56 for the high. So I think this is wrong. What am I doing here? No, this does not look wrong. It is the upper 8 bits. Right? Did I like invert them? Maybe. Just to be, let's be super pedantic here, because it's no, it is low high. Fine tune is register 13, and then coarse is 14. That's 11 and 12. So fine is low. Coarse is high. And then here we're getting clocked when our master divider clocks, like the other chips. Yeah, they really do make this distinction of 256 here versus the 16 over here. But then when they show the equation in terms of the TP10 here, they wrote 256 CT plus FT10. What's the this probably should have been 16 according to, you know, math. You know that thing? I don't know. Let me see. No, okay, it's not rewritten in terms of that. This has CT10 in there. Desired tone frequency. Input clock frequency. Decimal equivalent of tone period. TP is 11 to TP 0. This is written in terms of the coarse and fine tune registers, okay, where TP10, okay, TP10 is basically built from this. Oh, okay, I see. All right, so this makes more sense. So yeah, so this value here is unrelated to this one. This value here, 256, really has to do with the dividing of the time. So like this comes back to what I was saying. It really does look like, you know, we have to first divide the CPU clock like by 256. It can only clock the envelope period generator, sorry, the envelope generator every 256 CPU cycles, which would mean it should be even slower. And I just removed that. Like technically what I had was correct, this divider here, you know, because we have the master clock divider at 16 plus this one 16. I really don't get it. This would make it even longer, even slower, you know what I mean? Let me see, 30 to 125, and then they're saying with a, they give an example, using a 2 megahertz input clock, which is close to what we have, you would produce a range of tone frequencies from 30.5 to 125 kilohertz, and then here, because we have more bits, it would produce a range of envelope frequencies from 0.12 hertz, which is significantly slower, to then a larger value. Because, okay, so that's the thing, because 16-bit, right, that's really high. Yes, Pyro, exactly. That's exactly right. Exactly. I wasn't cluing in, but basically, this here, the EP10, which is what you just talked about, is what you do with the two different registers. The math of the period here being shift left the coarse by left by 8, and then ORing it with the fine tune, the other register here. So that's exactly right. And then it's just saying that frequency-wise, because for the envelope we supposedly have to wait 256 cycles, you know, the frequency of the input CPU clock is further divided by 256 here, and for the envelope, whereas for the tone generator it's divided by 16, right? What I don't get is if I do that, then we get really, really slow changes. Yeah, so you see this is actually, sorry, now I see, this is basically 7.8 kilohertz, which is lower than 125 for the tone register. So all of the math makes sense. So this is really supposed to be very slow, right? Am I wrong? Yeah, let me just look at this code a bit. So how am I dividing the clock? Okay, good question. So I have this master divider, which divides, so basically this will return true every 16 times we call clock. Otherwise it returns false. Yes, that's right. So I'll re-explain it there just to be sure we're talking about the same thing. So this function here on the PSG gets called every CPU cycle, right? Every CPU cycle, I call this master divider's clock function. This counts down 16 times. Once it's done, on its 16th, it'll return true, and it'll reset internally, okay? So then that means that what happens in here happens 1/16 of the time of number of times we call clock. So 1/16 of the CPU's frequency. Then, when we call the envelope generator's clock function, I have this further divider, which also is configured to be 16, like to further divide by 16. You know what I mean? So that means 16 times 16, which is 256. If my math is correct. I mean, okay. Another way to do it is just we could just pull this out like that, right? And clock it every single time, and then have it be, instead of 16 here, we could put 256 in there. And then that kind of like will, I guess, match more what's written in the document, even though I think that's strange. But let's just see if this makes any difference. Take off my breakpoints. So nope. And see, when I was setting it to like, so when we had it before, even every 16, it wasn't good. Just for shits and giggles, let's put 1. So this would be like every CPU cycle. I'm just curious what would happen. So it's definitely faster, too fast. And also we see that I'm going to bring it back where it was. We can hear that it's repeating. So that's another thing I don't understand. Our shape is not correct. So maybe that might be the hold current index. There might be something wrong here. Oh yeah, there is something wrong. I already see it. That's what's wrong. Here, so let's see. Yeah, basically I was checking if the shape index is less than the shape size, which is going to be pretty much always true. We want to say when it's less than the shape size -1, so that when it gets to the last index, then we continue down here to check if we should be holding or not. So that should fix that. And to see if that is the case, we reverted, and we'll just remove this divider again because otherwise it's too slow. And let's just see that even though it's slow, it should hold and stop and be silent after it explodes. So at least we know this code will be right. And then we'll try to understand what's going on with the frequency here. We are super close. Okay, there we go. So we did fix that bug. Did I get these wrong? Let's see. Just make sure my registers are indeed correct. I'd be very surprised or not, but Looks good. Hey, Danny Fritz. What voices does the Vectrex support? Just, what do you mean by voices? Do you mean like what kind of chips for audio? Because I know the word voices means different things. Like often it's used to mean channels. The Vectrex has 3 channels, and you can play. There are three square wave generators. Oh, hey, thanks for the follow, the Ragnar Lodbrock. Appreciate that. Yes, it's got 3 channels. It's got 3 tone generators, 1 for each channel. It has a single noise generator that can be assigned to 1, 2, or 3 or no channels. And it's got an envelope generator to basically modify the volume on any channel. So that's sort of the story there, if that's what you're asking. Yeah, you know what? It is a pretty good audio chip. I mean, it's not as complex as the one in the NES. The NES has like pulse wave generators, triangle generators. Yeah, it's got a lot more complexity, and I mean, hence we get more interesting music out of the NES. But no, it's a pretty cool chip. Man, we are so close. Like, what is going on here? Just pop this out here. No. Okay. Yes, you're asking if it's to support samples. So the chip itself, the PSG there that I'm implementing itself doesn't support samples, but you have the Vectrex can basically feed the analog, like, I don't know how to say that there, but basically past the PSG, you've got the analog signal there, and from the CPU you can basically directly output to this digital to analog converter and produce samples, like feed it sample data, and you'll end up hearing the samples. So by bypassing the PSG effectively, you can get samples, and there are games that do that. There's this one game, I forget what it's called there, with a cat and it speaks. So that's pretty cool. I'm gonna have to make that work. I'm gonna have to do that outside of the PSG and add like special support for that mode. Yeah, the overhead is pretty high. And you can imagine it also takes a lot of space on the cart to have the samples like in the cart itself. So very few games used it. That one game I'm talking about, I think it only has like 2 very quick sentences that are said by the character. And it's during the cutscene in the game. It's not during gameplay. So the CPU can kind of handle it, you know what I mean? So this sentence here, the envelope generator further counts down the envelope frequency by 16. I mean, I think what they mean is the fact that there's 16 steps here for one EP, right? Hold on. Oh, wait a minute. Am I doing this right? This here, we're supposed to have completed an entire cycle here for one period, where in fact what we're doing is we're just moving to the next value for every period. So that's what's going on. That's what's going on. Okay. That's not right. Okay, so what we need to do, what are we supposed to do? Yeah, okay, I see. What we do instead is okay. This is what we're gonna do. Did I write 12-bit value here? That's wrong. Okay, that's because I copy pasted from the other one. This is a 16-bit value. We're going to do something different. We're going to say period divided by 16 here. And we're going to try this. Basically, what I want is my internal timer to take the period and divide it into 16. And then we are going to advance 1/16 of the period, right? So that we can complete a whole cycle in one period. That's what I'm supposed to do. It's kind of like how for the square wave, we take the period divided by 2 to get the duty, right? Let me see. Okay, that's faster. Did I? Oh, I gotta put back my divider. Yeah. Yeah, so that's what they mean by the further 16. See, like that sentence there up here further counts down the envelope frequency by 16. The reason they mean that is that basically it's like it's cut up into 16. We want to do it in one complete cycle in one period. What we were doing is we were doing 1/16 of the cycle every period. So it was like 16 times too long. Still too long. Ah, so close. Why isn't this working? Oh, wait. No. Yeah. It's that. I just want to go look at how I computed the duty one. You can see here duty is basically it's the maximum of 1 in the period and then the result divided by 2. And I was doing 1 and the period divided by 2. Oh yeah, good question. It's still 16. Yeah, I reverted that change. Okay, let's just see if this works. Yeah, because I was setting the period to the maximum of 1 and period over 2. But when it's really small, yeah, actually, what happens when it's really small? I won't actually, yeah, so I guess under 16, periods of under 16 will just be every cycle. I guess there's an artificial limit there, isn't there? Does that make sense? No. Am I understanding that audio clock is called 16 times for every CPU clock? No, actually, it's well, at least the way it's supposed to be is that you have the CPU clock, and you first divide that. Like basically, the way they describe it is, it's every 256 CPU clocks we are supposed to update the envelope generator. When we update the envelope generator, we need to advance based on the period that we've set. Now the period, when we set it internally here, this period is a 16-bit value. It's reversed. This audio clock is 16 CPU clocks. Exactly. And then we have this further period that you can set. It's a 16-bit value, so from 1 to 65,536. And that period, in that period's amount of time, we need to advance 16 values. CPU frequency is 1.5 megahertz. Here they wrote 1 over the frequency of the envelope. Exactly. It's not really a problem with the audio sampling rate, though. I mean, if you're talking about the target audio sampling rate, right now it's 44,100. wait, no, that's still right. Yeah, no, that's correct. We set the period, update the timer to whatever is. Actually, this was right. I think the other one is what's wrong. The other one is not correct. It really should be. Oh, no, that's true. Basically, we just want to make sure that we... No. It should be like this. In this case, we're dividing it by 2. Yeah, I think it would make more sense if it was like this anyway. Yeah, so what's wrong is that the explosions are too slow. The sound, basically, it's basically the volume envelope is taking too long to fade out the sound, and it's related to the timings here. And reading the documentation, I think I'm doing this right. Basically what it is that I want the time to increment the shape index to be the period value that we've passed in, which is the 16-bit value, right? And so let's say we give it a period of 200. And what we want is that in those 200 cycles of the envelope generator, which happens at every 256 CPU cycles, we get one of these clocks. Like we clock this guy one time. During that one period, we would like to have advanced 16 values through here, because that represents, in the curve, like this here, this EP, the envelope period. We would have want to have done one of these. My lookup table contains 2 because that's what makes the difference, right? So I have 16 values and another 16 values so that we can represent shapes like this. I want to have moved through 16 values during one period. So to do that, what I think I can do here is I have my timer, this internal timer, right? That I'm using. So we have a period, we set the period, and we actually set it in 2 bits. We set the high part and the low part. Now, whenever I set any one of those, up here, set period high, set period low, in either case, we set this value, this variable to the value that we want, and then we call update timer, which reads this value here. And now what I'm trying is I'm dividing it by 16, and that should be the time to increment the shape index. That's what it represents. And if we look at how the timer is used, so first there's this extra divider, and this has to do with the fact that I have a master divider that's going at a frequency of 16. We could remove this again and come back to, if we want to follow the letter of this document that I'm using, and maybe that is the way to go. We say every CPU cycle, we clock the envelope generator. When we clock the envelope generator, we then we need this divider here. What am I saying? We need this divider, and technically this should be 256 according to the document. So what it's saying is, come up here, the frequency of the envelope is obtained in the PSG by first counting down the input clock, that's the CPU clock, by 256. So now it's more direct, you see. The input clock happens here in the PSG. We clock the envelope generator directly every time. We have this divider, that's what I'm calling this 256 counter. And so we wait until this divider returns that we've clocked it. Now, once that has been clocked, then I clock the timer, right? Because then it says, then by further counting down the result by the programmed 16-bit envelope period value. Now, this period value, I've cut it up into 16 so that I know that I can do this update value, which basically update value increments this index to get the next value in my current shape. This cur shape index here, it gets incremented by 1 most of the time, unless we're supposed to hold. But in general, you can just think of it as when we call this, we update the value and increment it. We update the value and increment the shape index. Let me see. I'm going to put a breakpoint in here. Let me just like debug this function a little bit, just make sure it does what I think it's doing. So the current shape index is 0. And hold current index is false, so now it becomes 1. Still false, so now it becomes 2, 3, 4, 5, 6. Yeah, so it's going to take a little bit of time. I'm going to put my breakpoint here. Let's do this. 8. Oh, and then became 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Gets to 30, 31. So at this point, hold current index is false. No, so the next time, we're at 31. Now we asked the question if we should hold the current index, and now it's true. This is what we expect. Our shape is 0, so that means that yes. Yeah, that's how I decided to do it. I decided to create a lookup table to really simplify this logic. Pyro gives me a data sheet. Yeah, that data sheet, Pyro, is exactly what I'm using. I don't know if you're giving that for Danny to look at. Basically, the table that we're talking about is built from looking at this here. Is this page 24? It doesn't even show me which page number this is. Yeah, it was for Danny. Okay. Yeah, so Danny, basically we built a table by representing 2 periods, 2 cycles, 2 EPs, because that's enough to, reconstruct everything, right? like for this, it's 1, and then the next 16 are all zeros. Here's 1 EP that goes up, and then the next 16 are all zeros. Then here, these two would be the same. Here it's going down, and then another of zeros. But then here we have down and up, right? So that's, and then up and down, you know. So for basically with two periods represented in our table, we can represent the shapes that we want. So now we're holding 31. Don't worry, it's not vodka. It's carbonated water. Don't want to get in trouble, you know? Twitch is going to come down on me. Okay. Let me think here. Oops. So set period high just ended up setting 256 as a value. Right. Passed in 1 here, which is 256 when it's shifted left, by 8. Why is it going crazy? Here we have a set period low with a value of 0. Now our period has some old value in it because we just wrote to the low bits. Let me see. Yeah, so we have zeros, the bottom 8. Well, a bit more than that, but whatever. So now our time becomes 896. It resets the time. And then F5 should give us a period high that's being set to a value of 8. So now our period is 14336. This seems to be the time that it really wants. clear out the low, set the high to 8. I mean, not 8, 56. Character 8. That's confusing. So 56. And then we want the timer to increment every 896. That's a good point, Danny. Let's... Danny, I was writing your name. Let's look up Mindstorm. I'm gonna just look it up again. Stop shooting. We don't get a chance to really hear one shot though, eh? But it's definitely too long for me. Just feels too slow. So I'm wondering, is this because, is there something I'm not thinking about here? We have 32 values. In one period, we should have reached. So one thing we could check actually is, yeah, that's one thing we could check is, like does it make sense hardware wise, right? It says that the idea behind it is that you set this period, and during that period, what am I looking at here? Sorry, here. So EP here, the EP is the envelope period. So during that period, this happens, right? And the way they're talking is you set this period value, and then it says, I don't really like the way they write it. Maybe I just don't understand. They say to the envelope generator further counts down the envelope frequency by 16. producing a 16 state per cycle envelope pattern. So I take that to mean that we will basically produce 16 values over the course of a single period. And that seems to line up with what we see. This is a single period. We will produce 16 values, and we can see it here. A single period produces 16 values. For 1010. Yeah, down, up. So in one period, we want to produce 16. And the way in my code, what that means is we would like that we would like to advance our value index, our shape index, basically 1/16, like 1/16 of the period. This is not. I don't need that comment. This is not right, is it? I guess nobody ever calls these functions, which is why we haven't seen this bug make any difference. Okay. So what I've done here is I've turned my timer rather into a timer that actually takes the the period and returns true every time a period occurs. I say return true every time 1/16 of that period returns true, because that's actually what I want up here. So actually, for each 1/16 of the envelope period, right, I want to change internal state. So in terms of my envelope generator, M period will contain the real period, but my timer will store this value divided by 16, so that when we call clock here, first we'll have this master divider, which is the one that says, divide the CPU frequency by 256. After that, every time that is true, so every 256th CPU cycle, I then use my timer to know, did 1/16 of the period elapse? Once 1/16 of the period has elapsed, update value will update value to the next, well, anyway, to the current shape index, and then increment current shape index, unless we need to hold the index on the last value. But that's just a special case under certain things. Like, and it's the case for all of these shapes that have like the same value at the end. We end up actually going through all of this, even though it's all zeros, but it doesn't really matter. Okay, so one thing we could do, I don't know if it's going to be helpful. Could be helpful. Yeah. Let me do something. I wanted to do this. Let's actually show what's going on in the envelope generator, just like we did in the audio driver. I'm going to copy some code here. I guess actually I could do value. Then we'll do I'm gonna generalize this at some point, but for now it should be fine. What? No. There. Okay. And then we'll do a plot lines. And we'll say and here we'll say 1 to 15. The reason why I divide by 2 in the tone generator is just because one period for the square wave generator consists of doing like both a high and a low, but exactly the same. So, you know, half a period, we call the half a period a duty. So if you think about like a sine wave, right? We want to basically do the high part and then the low part. And that's why I divide by 2. And I was wondering if I should be putting divide by 32, but I just can't reason about why that would be correct. unless I'm missing something. Because the fact that here it says EP is this, that's basically what I want, right? I want to be able to do one of these in one EP. If we go back to tone generator, although I don't think it says it in the tone generator, but it's because we know it's a square wave generator, right? So it's not really going to say it. But it's just like the nature of a square wave generator. But for sure, dividing by 32 would double the speed. And it might sound right, I just don't understand why. Let's see. Oops, okay, yeah, that's true. Can't do that. Why is it again? No, this should have worked. What? Why am I getting multiple envelopes here? Oh. No. Yeah, this is all right. Static, 10,000 values. Oh, right. Yeah. That's true. I can't do this here. Not every CPU cycle. Okay. So I always have an... Okay, I do have an update. This needs to move out of here. I'm not sure, but the envelope period is always 16 steps, but the period set through register is for the frequency in which you change the step. Sorry, I just lost the window there. Why is this not working? Sorry, let me read what you wrote. I'm not sure, but the envelope period is always 16 steps, but the period set through register is for the frequency in which you change the step index. if you're right, Pyro, then what's this image showing us here? Yeah, like we see here, it even says 1 over FE. So like basically, you know, the frequency of the envelope, which is the number of times per second, 1 over that is the seconds per thing, the period basically, and that's what EP stands for. And it's showing here that in one EP we do like one shape like this. In the 1010 case specifically, where it goes down then up, it would take 2 periods, right, to produce this. Everything seems to be pointing to that. Yeah, everything seems to point to that. I feel like there's something else going on, and hopefully I'll be able to see it. And I don't know why though, this does not seems not to be working. This gets called once now per frame for. Oh, it's not called once per frame, is it? Yeah, it is called once per frame. Let me see. Yeah, frame update, which calls via update. The via update calls a PSG update. So that's once per frame with the number of cycles. So what's going on here? The hell? All right, this is actually not called once per frame. Still being called once per CPU cycle. I need to give this different names. I have this kind of confusing nomenclature. I like how I'm calling the functions clock in the audio code because it's very clearly related to the CPU clock. or the basically whatever rate that the clock is supposed to run at for that chip, but I don't have that same nomenclature for other things. Here I call this update, but really it should be like this is like on CPU instruction. And that's why I can't do what I'm doing right now. Update is not a good name. Okay, let me do this. That's actually what I usually call it. I will rename those updates at some point, but frame update I do use when it's once per frame. I'm going to do this. I believe my Via has a frame update as well. Let me see. Yes. I did it for the same reason. I wanted the screen to have a way to do some frame stuff. And I need to pass the delta time. I guess I don't really need to, but I guess I should always pass it. Why didn't I pass the delta time here? Okay, you know what? Let's keep it simple. We'll get to the point where if we need it, we'll add it. Okay. I just want to see what the shape looks like. Might be an indication, and it might help us to understand what's going on. If the shape looks weird, is it smooth, you know? Does it look odd? Let's see. It's just useless. The weird thing there that we see is because I'm moving my ship, I think. Trying not to get hurt here. Oh, there's a bit of a weirdness there, but... Yeah, another thing too is I'm not taking the time into account. So if my frame rate is, that's why it's not perfectly smooth. If my frame rate changes a little bit, we're gonna notice little bumps like that. Because this is frame based and not time based. Well, nothing sticks out right now with that. So, you know, just to see there, let's try and do the divide by 32. I don't think it's right, but it'll probably sound right. Okay, that does certainly sound a lot more like it. Yeah, so Pyro, I mean, I think you're right. I do think it's 32. I don't think that that's what should be here. There's something else going on. Maybe it's the fact that I have 32 values and I'm not thinking it straight. But I don't really understand it. Unless it's wrong. You know what I mean? Unless the documentation isn't exactly right. One thing I also wonder about is, like, what happens if the value we store isn't actually a multiple of 16? All right, Pyro. I think I'm going to go to bed as well. But thanks for hanging out, man. I think I'm going to go to bed and I'm going to let this stew a little bit. And when I come back to it, hopefully something clicks. I mean, obviously we're super close. Like this is definitely practically there. But yeah, thanks, man. Take care. Where was that document that I was looking at last time about the noise? Did I like lose that one? Four divided by 64 divided by NN. So this does not match the documents. Here it's saying it looks like it would be at the same frequency as the other chips, really, which honestly seemed to make sense hardware-wise. I don't know about that 256. Let's see if we were to do this at the same rate, like it's saying here, and then go into the envelope. Where are we here? Envelope. This divider, we just removed it. How would, and then we just use the internal timer and we go back to dividing by 16 here. Basically, like, let's just clock it exactly like the other chips. So at every 16 CPU cycles. And then let's just use the internal timer will be every 16th of the period. Let's see if that actually works. No, it's too fast. So that's not right. The completion time for 16 steps is therefore, let me see. I wonder why they say 64 actually. Where does the 64 comes from? messed up. Yeah, not sure what's going on here. That's interesting. The volume is non-linear. I should probably do this. To convert it. That's interesting. Because I'm definitely just treating it as a linear volume. I can't help but wonder if the time is correct, but it's the curve that's wrong. What is it? Right. Actually, if I just do this, I should promote to float. Yeah. Okay, this will be my last try. If I don't get this, I'm going to stop and we'll figure this out next time. What? Okay, that did not sound good. Oh, max. Okay. Right. I'm not even doing this right. I need to divide 15 by this. And then, I see. It's actually, that's it. Sorry for the explosive ear damage there. You know what would be really useful? Save states. I could stop doing all this fast forwarding. Maybe I'll do that at some point soon. Okay, so clearly that's not working. But maybe with the divider working at 16 here again, and the other 16, so we go back to the 256 that we were talking, maybe that will do it with the shape here. This actually might be right. This actually might be right. It's long, but I don't think that's wrong, because you know what? Before I go, let me just try the Vectrex emulator here. This emulator emulates sound, and I'm very curious. And his is really quite accurate, so I think it's a pretty good thing. Otherwise, I'm gonna have to pull out my Vectrex, and maybe that's what I'll do for the next stream. But let's try this one. Yeah, you see it's pretty long. Yeah. I actually don't find it sounds really great, to be honest. No disrespect to Vectrex, but I don't know if it's a configuration thing. PSG sound, master, volume, PSG volume. Doesn't seem like it has any way to play with the audio, but anyway. But yeah, I think we got it. I think with that, with the curve of the volume being corrected, and I'm going to move this out of here. This is not the right place. But with the curve of the volume now being correct, and the timing back to what I believe that should be based on the documentation. I think that there's something very interesting that I read also about the mixer. We are adding the signals of the noise and the tone, and when I fire, it doesn't sound correct. That doesn't sound right. And actually, I'm wondering if we change it to do what it said, instead of like adding the signals, we were to AND them, the values, I should say. So I'm going to put a little to-do about that, because I don't feel like it sounds right. See, here we're just doing a plus equals for the noise generator. And maybe what we really want to do is get back this value which is a 0 to 1 value. Yeah. So that's it. It's kind of like if it's already on, it's on. That's interesting. But, or more like both have to be on for it to be 1. Does that make sense? That's it. Both have to be on for it to be 1. All right, so a few things to do. I'm going to put a little to-do here. If both channels are on, then we only get a 1 if both tone and noise return 1. Otherwise, it should be 0. So we should do that. But before that, I also want to do here a little note that basically what we want to do is this. Not get fixed volume ratio. Oh yeah, so there's a question. Does it apply to this one? I guess it does. And then where was that bit about the here? too big. Okay, so this way we are also applying it to the fixed volume. Because I mean, this is really the shape of the actual speakers, you know, like the volume, how we hear it on the speaker, and should be applied to the final value no matter what. Yeah, you went 32. Oh, I messed something up. Oh, the classic. Good old fall through. Man, that's a lot of popping. Oh, that sounds better. Interesting. That actually sounds better. I'm getting some CPU fluctuations here. I don't know what's going on my machine. Oh, you know what it is? It's because I'm running this other emulator in the background, isn't it? Let me shut that down. Try and get back some CPU here. There we go. Let me reboot. I want to hear it again. It sounded really much different now with the curve being applied. All of this sounds better. Oh yeah. It's much more punchy. Yeah, really what the last thing is the playing both at the same time. That's not correct. Can't go to bed yet. It's just too close. So if we do it this way, then actually it's not 6 we need to divide by, it's 3. Because this counts as 1. And that actually makes more sense, 3 channels. It always kind of bothered me, the 6 thing. Let's see if this sounds right when we fire. Very interesting to hear this. Basically, it would mean we hear the noise at the frequency of the tone, right? Why is my CPU so crap? What the hell's going on? My CPU keeps dropping. I mean, my frame rate keeps dropping. Ah, that sounds much more correct. Although, is that correct? I think it's right. Sounds good. Just before I go to bed, let me just try my favorite game. Just curious if it'll actually sound good. There's a weird high-pitched sound there. Man, it does sound pretty good though. That doesn't sound good. So there seems to be still a couple of minor things that are not quite right there. No, that's a weird sound there. But overall, pretty cool. Pretty cool. No? Wondering if one of these why isn't this? Oh, it's paused. That's why. I wonder if this Beverly Hills Cop audio will play. Not supporting I/O ports on the PSG. Oh, does it actually try to write to it? Okay. Okay, so this is probably how sampling is done. Okay, these are probably doing samples. Okay, that would make sense. I don't have a reset yet, do I? No. Okay, well, I think I've gone well over the normal time, so I'm gonna stop here. And so yeah, thanks a lot everyone for watching, and I should be back next week on Tuesday, continuing on wrapping up this sound emulation. So thanks again, and see you next time.